Hi everyone, and thank you for joining this talk. My name is Aleksandr. I'm a product manager in the Nebius. And today I actually want to talk to you about why every AI cloud provider needs an in-house language model team. Why it's personally important for me, why I decided to talk about it. Because before joining the Nebius, before becoming product manager, I was a solution architect in AWS working in machine learning space. And I could say that without experience which I get inside of AWS, I could not become a really good product manager. And this is the topic that I want to explore with you. I would like to start with a quote of one of the wisest men that I met personally in my life. His name is Werner Vogels. If you never met him, if you never saw him, this is a CTO and vice president of Amazon. And back in 2017, if I'm not mistaken, he said that there is no compression algorithm for expertise. It means that you could not learn certain lessons without going through the curve. In other words, you could not understand how to do things good if you never done those things. You need to do something by hand to learn how to do that. No way. And why it's important for me and why it's important for the Nebius. To answer this question, let me give you like 2 minutes overview who actually the Nebius and what we are doing. So we are the AI-centric cloud platform building globally to help AI industry grow. And when I say globally, it actually is. So we have offices in Europe, we have offices in the US, we have data centers in Europe, and we're going to have data center at the beginning of the next year in the US as well. Internally, we are close to thousands of the people, and this is actually high-tech skilled engineers. And we're working with the NVIDIA, we're building and operating data centers, and it's actually quite interesting data centers. For example, our data center in Finland is hitting the next town to the data center. And why we actually not the usual, let's say, cloud provider? Because we actually own data center, we're building them, we own the hardware, we're not buying hardware, we're actually producing the hardware. We're designing boards, we're designing chassis, we're building our own cloud platform, so we're writing the software, we have a lot of software developers, and we have our own language team. So if you will recall what I said at the beginning about the expertise, if I will paraphrase it, I could say that to actually build AI-centric cloud, you have to know what is AI. You need to have expertise in AI. And in this talk, I want to highlight a few challenges from the AI and how we transform those challenges into the products and the features inside of the products. About the language team who help us, who give us a lot of insight. So this is our own team, and one of the projects that they have done is a training of 300 billion models on more than 1,000 of GPUs for a month, and the final feedback that we get that they were sleeping well, and this is super good to hear that from a team who's working on the big clusters. Beyond that, today I'm going to highlight just few challenges, and these challenges are coming from working with our language team and also with our customers. You probably know some of them. Regarding the training the model in general, you know that there are multiple steps that you need to go through, like data preparation, training, doing alignment after the training, and then you do inference. On each step, you will notice different challenges, different problems that needs different solutions. But today, because we have just 15 minutes, and I already used 4 of them, I will highlight just 2 challenges from most expensive stage, from the training, because this is where you use like few thousand GPUs and where the cost is going to millions. So the challenge number 1 is about getting the cluster. First of all, it's really hard to get the big cluster. And when I say big cluster, it's not just big amount of GPUs, it also means like with the storage, with the InfiniBand connection between all nodes and all GPUs. So you cannot just open the browser and buy 4,000 GPUs nowadays. The second thing, if even you could find it, you could not really switch between them because Everyone have a different microcodes, version of the drivers of the software, and actually the combination of that could bring a lot of challenges. And you can spend a lot of time just trying to understand what's going on. Another thing that you might face is that you can say you need a cluster, and the time to provision that cluster, especially if it's doing manually, will take weeks or even months. And the last thing, if you have unstable and unreliable cluster, you will need to restart your training continuously every day, every few hours, and you will burn a lot of money just for nothing. So what a best practice we can recommend in general? First of all, before you actually launch a job, before you actually buy a big cluster, try a smaller one and do a few tests. First of all, test the networking through the NCCL. Then try to launch some pre-built software trainings, like ML Commons will be a nice option to start. And do not focus only on training or only on inference. Do both, because training and inference have absolutely different patterns in a workload. And if you do training tests, it doesn't mean that everything will be good for the inference. Do differently. And what we are doing, like as a features for the cluster. So first of all, we do everything automatically. We do not provision hardware, software manually. It's all programmatic. For every cluster, while we have it on a factory and then in a data center, we actually do NCCL testing. We run ML Commons distributed training job. So we do big inference for the 405 Llama with array, and we do full-scale pre-training. So only after we complete all those steps and we notice there are no mistakes, no problems, no errors, we can give you a cluster. Not before. Just to make sure that you will not face the problems while you will do your job. The second challenge, everything fails. And if you take a look on the paper from Meta about how they trained the Llama model, you will find that they use 16K cluster, and you will notice that they also exposed how many interruptions they had. And they have planned interactions and they have unplanned interactions, and there was 419 unplanned interactions. If you will just do a simple math, you will find that the cluster of 16K GPUs were failing every 3 hours. So it means that every 3 hours you need to restart the job again and again, and not to restart from the beginning, you do checkpoints, like you save your status, like you do in the games. But the problem with the checkpoints is that, for example, for the 300 billion models, the size of the checkpoints is 3.6 terabytes. You need to save that data every time, and you need to version that data every time. And how actually it will take, why it's a problem. The first thing that when you do a checkpoint, you cannot continue the training. So actually you freeze your cluster for that time. And if you just natively write checkpoint through the 5 gigabit per second network, theoretically it will be 19 minutes. So 1.5 hour cluster is doing nothing. And it's theoretical number. So in reality it's bigger. There are two ways how you can reduce that time. So the way number one, you need to do distributed checkpoint. It means that instead of writing from a single node, you write from all nodes, small pieces. And theoretically, if you utilize 5 gigabit network, you will need around 45 seconds. In reality, we were able to achieve 180 seconds, just 3 minutes to save 3.5 terabyte of the data. But that's not all. So this is a time when you do writing of the checkpoints directly to the storage. Instead of that, you can do that in 2 steps. So first of all, write checkpoint to the RAM, because your RAM is doing literally nothing, almost nothing during the training. You have a lot of RAM in a big cluster. Just write it there, and it actually takes just 1 second. And as soon as you complete that, you can continue the training, while the second process will take the data from the RAM and stage it to the file store, to the persistent storage. As a result, we achieved 1 second to save 3.6 terabyte checkpoint to the storage. So to summarize, to work, to help yourself with the checkpoints, use asynchronous writing and use distributed writing. And by the way, that's the same way how you can do that to restore the checkpoints. Because if you failed, you need to restart, and it means you need to read 3.5 terabytes of the data, and you can do that. So how we are doing that, we read them distributedly, and then we exchange small pieces through the InfiniBand, which is super fast. And we can restore just in a couple of minutes and continue the training. If you're doing that, just you do that and you will get a really nice checkpoint speed. But what we have done as a provider, as a service provider to help you, so if you don't want to do that, or you have the smaller size of the data set, of the checkpoint, of the model, first of all, we designed our storage to provide you with 150 gigabyte, not gigabit, gigabyte per second. That means if you have not so big model, you will be fine just to write it directly without any distributed or synchronous. And the second thing is actually we can help you to set up the same thing, same distributed, same asynchronous checkpoints. This is what we can share openly. And actually, one of our services have all those things like built in. You can just use it without getting inside how it's work. Okay, so those are two challenges, and this is why it's important to do machine learning to actually build a really good AI-centric cloud provider. Because if we were not running those jobs, we will never find out how we need to build the storage, because the storage have a workload pattern that you need to optimize. You need to optimize network, you need to optimize services, the libraries. So this is important to get expertise to build something. And we're doing different things. And what we have built so far based on that expertise which we get. So first of all, we're starting and we build the hardware. As I said at the beginning, we're actually building our custom hardware. We're not buying that. And this is like a base layer for us, where we're starting. But no one will get access there. We do not provide access to bare metal service. We provide access to the software stack, to the platform. And to help you to work with that, we already have a managed Kubernetes, managed Slurm. We created multiple storages like block, file, object storage. We have actually virtual networking, so it's full VPC. And on top of that, we also build a platform. So you can have managed Postgre, managed MLflow, managed Kubernetes, managed Spark. And we also prepackaged many important things like Airflow, Ray. And when I say prepackaged, it means that you can just deploy them by one click. And it's not just playground. It's actually they design it and they template it in a way to be highly available. For sure, to work with that, we built it in a UI. We built a Terraform provider so you can actually provision that fully automatically. We have a nice documentation, and just last week, we released AI Studio, which is inference per token. So if you want to use open source models and pay per token, now we build that AI Studio. And we build it on top of the infrastructure. So that means you automatically get all things about speed, reliability, and ease of use. So check it if you need it. Regarding the Ray, because Ray is super important, we use it for the test as well. So we prepackaged the Ray, and you can deploy it with one click, and you get Ray running on a Kubernetes with a kube already installed, with all drivers installed. You'll get two node groups, one for the head nodes, one node group for the compute, with automatically scaling based on the workload. And it's just you will get it by just one click. Okay, so we're actually coming to the time. If you want to learn more about the challenges, feel free to find us on the G1. It's just opposite corner. It's easy to find us. We have nice T-shirts. If you want to stay connected with me personally, you can find me on LinkedIn. It's easy. And again, feel free to come to our booth. Thank you so much.